Hey guys, this is a recording for PreCalc. We are going to first start with going over these counting principle, permutation, and combination task cards. So pay attention, make sure you have your workout so you can check yours. Okay, we'll just go ahead and start with the odds. So this first one, it's talking about a basketball team and we want to choose 5 starting players. The order does not matter, so we know that this is a combination. There are 11 players to pick from, so that means N is 11. We're trying to choose 5 players to put out on the court for the starting people. So what we need to calculate is 11 choose 5. That gives us our answer. There are 462 different ways to choose the 5 starting players. Next one, number 3. There are 125 juniors at a high school. How many ways can they elect a president, vice president, and secretary? Since this one, the position of the people matters, it depends, it matters who gets vice president, who gets president, and who gets secretary. This is a permutation. Each spot is different. The number of total students to choose from is 125, and we are trying to fill 3 spaces. So this is, to find our answer, we need to do 125 P3. When you plug that in your calculator, you should get 1,906,500. That's how many different ways there are to elect the vice president, president, and secretary for their grade. Now number 5, it says she wants to bring a dessert. They have 8 pies to choose from. How many ways can she choose 3? It doesn't matter what order she chooses the pies in, so this is a combination. There are 8 pies to choose from, so that means N is 8. And this girl wants to choose 3 of them, so R is 3. So to calculate our answer, we'll do 8 choose 3, and that should give you 56. Next, for number 7, Eric gets to choose from 5 cake flavors, 7 icing flavors, and 3 topping flavors. He can only choose 1 of each. How many cakes are possible? So this one, you can either do it as a counting principle problem or a combination. So you could either do this as a counting principle where you're saying he needs to choose cake, icing, and topping. He has 5 choices here, 7 choices here, 3 choices here, and multiply those together. That'll give you 105 different combinations for the cake. Or you can do this as a combination problem. So for our first event, for choosing the cake flavor, there's 5 options and he wants to choose 1 flavor. Second, for choosing icing, there are 7 options and he wants to choose 1 icing. The third event is choosing a topping. There are 3 options and he wants to choose 1. If you multiply these 3 together, it'll also give you the same answer, 105. So either way you did this problem is correct. Okay, number 9, there are 12 Girl Scout cookies that are different types. How many ways can she choose 3 different kinds to buy? So choose is a very important key word in this problem. Choose tells us the order doesn't really matter. We're doing a combination. So there are total 12 different flavors to choose from, and we want to pick out 3 different flavors. So to solve this, we'll do 12 choose 3. That gives us 220. There are 220 different ways that she could choose 3 flavors. Okay, on the next page, we'll go ahead through these odds also. It says Justin took a quiz with 5 multiple choice questions and 5 true-false questions. The multiple choice had the answers A through D, so that means there were 4 options. How many different ways can he answer the questions? So for this one, I would do it as a counting principle problem. The first 5 questions have 4 options, A through D. 4 times 4 times 4 times 4 times 4. This is the same as 4 to the 5th. The next 5 questions have 2 options each. So that'll be the same as 2 to the 5th. When we multiply this all out, you get 32,768 different ways he could answer these questions. For number 13, he's trying to come up with a 3-digit PIN. He can use the digits 0 through 9. So that means that there are 10 possible numbers to fill in each space. I would use a counting principle to solve this problem. Whoops. So we have the first digit in the PIN, second digit in the PIN, third digit in the PIN. For the first space, there are 10 options. Since it doesn't say that the numbers cannot repeat, the second digit also has 10 options. The third digit also has 10 options. So 10 times 10 times 10, that's the same as 10 to the third. There are 1,000 different pins that he could come up with. Number 15, how many different 10-letter arrangements can be made from the word basketball? For this one, I don't expect you to have gotten this answer. If you did, that's really awesome, but it's a little bit difficult. So since we are talking about letter arrangements, the order matters. It's a permutation. So total, there are 10 letters to arrange, and we want to put 10 letters, all 10 letters in order. So that means N is 10 and R is 10. So we know that we're doing 10P10. However, notice that if we switch the spots of these 2 B's or these 2 A's, well, that's way bigger than I thought it was going to be, or the 2 L's on the end, anytime we switch those letters, it's going to come up with the same combination, the same arrangement. Let's say we switch those 2 B's, it's still going to be the same arrangement of letters. So what we need to do here is we need to divide out the repeats. So there's 2 B's, 2 A's, and 2 L's. So whenever you have repeated letters and they're asking for an arrangement of the letters, you need to make sure you divide out the repeated letters or numbers. When you plug this into your calculator, it will give you your answer, which is 453,600 different arrangements with the letters in the word basketball. Number 17 is about this cross-country race, and we are putting the runners in order, first, second, and third. Since the order matters, this is a permutation. N is equal to 18 since there are 18 people in the race. R is equal to 3 since we're talking about first, second, and third place. So to solve our answer, we need to plug 18P3 into our calculator. That'll give you that there are 4,896 different results for this race. Number 19, we're talking about a 4-letter password. The first letter has to be a vowel. So I would do a counting principle on this. Total options for the first letter is 5, since there are 5 vowels in the alphabet, A, E, I, O, U. The other 3 spaces, it does not say that the letters cannot repeat. So all the other 3 have 26 options. You could do this as 26 to the third. So we have 5 times 26 to the third. There are 87,880 possibilities to choose from to make her 4-letter password, with the first letter being a vowel. All right, let's go ahead and move on to the evens. Number 2, we're talking about a softball game, and we're trying to make a batting order. Since it's a batting order, it's a permutation because the order matters. It matters who bats first versus who bats second. The total number of players that they're putting in order is 10. And I'm not sure if you knew this, but in a batting order, there are 9 players. So if you didn't know that, don't worry about it. Just correct it now. So this one should be 10 P9, which gives you 3,628,800 different lineups for the batting order. Number 4, how many different 4-letter arrangements can be made using the letters in the word rhombus? For this one, we're talking about ordering the letters, so it's a permutation since order matters. There are 7 letters in this word, and we want to put all 7 of we're not putting all 7 of them in order. Let's read that question a little more carefully. It says the number of 4-letter arrangements, so we're only putting 4 of them in order. So what we want to do is 7P4. There are no repeated letters in the word rhombus, so we have nothing to divide out, no extra letters that are repeated. So your answer is 840. Number 6, we're talking about putting the violinists in order because we're seating them. So the spot that they're sitting in would matter because they're putting them in order in the front row. So this is a permutation. There are 8 people that need to be seated, and we are seating all 8 of them. So to find the answer, you should do 8P8. Which should give you 40,320 different ways to put the 8 violinists seated in the front row. All right, number 8, there's 14 candy bars. How many ways can he choose 5? Remember, the key word choose means that we're doing a combination. The order that we choose the candy bars does not matter. N is equal to 14 since there's 14 to choose from. R is equal to 5 since that's how many he is going to buy. So to find the answer, you do 14, choose 5. That gives you 2,002 different ways to choose 5 candy bars. Number 10, the Nebraska license plate has 6 characters. Each one is filled with a number or a letter. How many different license plates are possible? So for this one, I would do counting principle. Since we are using, let's see, it's 6 spaces to fill. And each one uses a number 0 to 9 or a letter. So that means each space has 10 numbers to choose from plus 26 letters to choose from. So in total, there are 36 options to put into each space. it doesn't matter if we repeat letters or numbers. It doesn't make that specification in the question. So the answer for this, you could also do 36 to the 6th power. The answer is 2,176,782,336 different license plates are possible in Nebraska. All right, next, number 12, we're talking about these appetizers. You could choose this as a counting principle problem, where the first event is choosing an appetizer, the second is an entree, the third event is choosing a dessert. So for appetizers, you have 4 options. Entrees, you have 9 options. Desserts, you have 3 options. Multiply all these together, you'll get your answer, 108 different 3-course meals. You could also solve this as a combination though. So for example, for the appetizers, there are 4 choices and you want to choose one. For entrees, there are 9 choices and you want to choose one. For desserts, there are 3 choices and you want to choose one. Multiply all of these together and you'll get your answer, 108 different 3-course meals. Okay, next, number 14. Brianna's school day consists of 6 classes. How many different ways can her schedule be arranged? So obviously your class schedule, the order matters. This is a permutation. There are 6 classes, and we want to put all of them in order. So R is also equal to 6. So to solve this, we need to do 6p6. There are 720 different ways to arrange the 6 classes in her schedule. Okay, next, number 16. If Lucas owns 11 hoodies, how many ways can he choose 4 of them to bring on vacation? It doesn't matter what order he chooses them in, so it's a combination. He has 11 to choose from, and he wants to choose 4 of them. So N is 11, R is 4. So we'll do 11, choose 4 to solve our problem. That gives us 330 different ways that he can choose 4 hoodies to bring on vacation. Okay, number 18, Rob is one of 7 children in his family. How many ways can his parents choose 4 siblings to do chores? So for this one, we're just choosing the siblings. It doesn't say that, like, Robbie is doing sweeping and Sally's doing the dishes. It doesn't say that the order or the spot of the child matters. They're just all doing chores. So that's how we know that this is a combination. And it also uses the keyword, they're choosing the siblings to do the chores. So total, there are 7 kids to choose from. His parents only want to choose 4 of them though, so R is equal to 4. So to find the answer, we'll do 7 choose 4 on our calculator. That gives us 35. Okay, next, the last one, number 20. There are some options. You could do this as a counting principle problem. So our events are choosing pants, choosing a shirt, choosing a tie. There are 5 options for pants, 9 options for shirts, 6 options for ties. That gives us our answer, 270. Or you could do this as a combination problem. There are 5 and we want to choose 1 pair of pants. For shirts, there are 9 options and we want to choose 1. For ties, there are 6 options and we want to choose 1. If we plug that in our calculator, it will also give us the same answer, 270 different ways, different outfits that he can make with one pair of pants, one shirt, and one tie. Okay, make sure you get those corrected. I wanted to go over a little bit more with probability with you today. So what I want to do is show you these questions. So let's say, suppose that you have 3 pink marbles and 5 blue marbles in a bag. If you see a question like this, basically what this is asking you is what's the probability that you're picking 2 blue marbles? Assuming that you're picking 2 marbles, what's the probability that both of them are blue? The second question over here is saying what's the probability that one of them's pink and one of them is blue? You're going to see some questions like this on your homework tonight, so I just wanted to make sure that you knew what this notation meant so you know how to answer your questions. So let's talk about this. So there are 2 different things we need to consider here. Either we're picking the 2 marbles at once, or we're picking 1 marble then replacing it. So let's just deal with the first situation, picking the 2 marbles at once. So the total number of possibilities would be there are 8 total marbles, and we are picking 2 of them. So we'll do 8 choose 2 to figure out the total number of possibilities. So go on your calculator, type 8 choose 2. So there are 28 different ways to choose the 2 marbles. And this is saying what's the probability that they're both blue for the first question. So for this first question, we need to figure out, remember, probability is always equal to the number of outcomes in our favor over the total number of outcomes. So what we need to do is we need to figure out how many different ways can we choose 2 blue marbles. So what we would do here is there are 5 blue marbles and we want to choose 2 of them. And we already said that that's out of 28 total. So let's go back to our calculator, type in 5, choose 2. Gives you 10. Out of 28. That reduces to 5 over 14. Which you could also change to a decimal or a percent. So it's 35.7% probability. Okay, so for the second one, what you need to do is they're asking you what's the probability that they choose 1 pink and 1 blue. So what you need to do is you have 3 pinks to choose from, so it's 3 choose 1 times 5 choose 1, and it's still over 28 since that's still the number of outcomes for choosing 2 marbles. So we'll go to our calculator and we'll type in 3 choose 1 times 5 choose 1. Well, actually, that's just going to be 3 choose 1 is just 3, 5 choose 1 is just 5, so that's 15 over 28. that gives you 0.535. Which is 53.6% probability of choosing one pink and one blue. Okay, let's finish up this other situation. You're picking one marble, then you're replacing it. So first things first, we need to figure out the total number of possibilities. I would treat this as a counting principle problem. Event 1 is picking the first marble. Event 2 is picking the second marble. So in this case, picking the first marble, total there are 8 marbles to choose from. And then you replace it, so the second event, there are still 8 marbles to choose from. 8 times 8 gives you 64 different possibilities for choosing the first marble, then choosing the second marble, if you're doing a replacement. Now let's talk about these two different questions. So the first one's asking, what's the probability that there's 2 blue? So basically what this is saying is that the first one that you choose is a blue marble and the second one that you choose is a blue marble. So let's think about that. Event 1, there are 5 blue marbles to choose, so there's 5 options that would go in your favor. Event 2, there's again, since you would put the blue marble back, there's still 5 blue marbles to choose. So you would have 5 times 5 over the total, which is 64. So that's 25 over 64. That is 0.39, so 39%. And it does not reduce. So you have a 39% probability of choosing a blue marble, putting it back, and then choosing another blue marble. Okay, the second question was asking what's the probability of choosing one pink, then one blue. So for this one, there are 3 pinks to choose from for the first marble, and 5 blues to choose from for the second marble for event 2. So that's what would be in your favor. The total number of possibilities is still 64. So you get 15 over 64. So that's 23.4%. And it does not reduce. So you have a 23.4% probability of picking a pink marble, then a blue marble. Okay, here are your homework problems for tonight. I hope you have a great rest of your day. Bye, guys.